Hey there everyone, all the techies and data enthusiasts there. So guys, welcome you all to my YouTube channel, and I would like to inform you all it's been 78 years since India got its independence. So guys, on this occasion I would like to wish you all happy Independence Day, and here is a special video for you all on this Independence Day. Today we are going to discuss about LLM Ops. So what is LLM Ops? And what all are the tech skills you should know to become an LLM Ops engineer? And if you are building your own LLM application, how can you deploy it? So we are going to discuss about this particular topics in detail. So guys, if you are not subscribed the channel, do subscribe the channel and on the bell notification for more interesting videos like this. Now let's not waste our time. Let's dive into my computer screen. So guys, here you all can see my whimsical here. So the same way I created for ML Ops, right? The roadmap, the same way I have created for LLM Ops as well. You all can access this link. This link will be in this video description. So I'll start to explain one by one. Okay. So firstly, introduction to LLM Ops. So you should basically know the introduction, or you should know a high level overview about LLM Ops, you can say, like the overview of LLM Ops and the definition of LLM Ops and its significance in a machine learning or an AI life cycle, you can say. So when it comes to machine learning, it's different. You have ML Ops and you used to train the data on it, and on our data you have to train a model, and there used to be a CI/CD pipeline integration. So each time there is a better improvement in the model, the CI/CD used to integrate it. That is the role of an ML Ops engineer, and he used to monitor the model lifecycle. But here in LLM Ops, you already have an LLM models. LLM is nothing but, you all know, it's a large language model. So there are already a pre-trained models. So based on that, how you all can learn and how is it different from ML Ops, that we'll be discussing today. Importance of LLM Ops for scalable and maintainable LLM systems. So how important it is to maintain and how scalable a particular LLM Ops system it is. So you should understand about these particular topics. Then comparison of LLM Ops with traditional ML Ops and DevOps practices. In short, so if you all have learned previously about ML Ops or DevOps, if you have an idea on it, so you will get to know, like you have to compare what is the difference between ML Ops and DevOps. That is your first task. Once that is done, then you have to again compare how is LLM Ops different from those both. So it's a bit unique, right? So in ML Ops and DevOps, you guys used to access the AWS cloud, and you used to even load the data, create a models, write the pipeline architecture to create a models and deploy it. But here in LLM Ops, you have a pre-trained model. So how is it different from your traditional ML Ops and DevOps? You should know about this particular topics. So once this is done, you have LLM architecture. So the LLM architecture is again divided into high level overview, tokenization, embeddings, attention mechanism, and text generation. So you guys are feeling, you have heard it somewhere. So if you already learned NLP, I guess you might be feeling this. These all are kind of similar concepts which you will see in NLP, and even for generative AI, you should know about them. So if you want to become an LLM Ops engineer, first you should know the high level overview, the core components of LLM architecture and their functionalities, what a particular large language model can do, and how is it, so whether it's a closed source model or an open source model, and how accurate that model is giving the output. You have to know the detailed architecture about those particular models. So when it comes to closed source, you have OpenAI, Mistral. When it comes to open source, you have Llama models, and even there are many more models. Pi3 is there from Microsoft. Llama 3.1 was a very huge success, you can say. You can check out that particular model. Actually, this is a beginning phase. All these models, now we all feel that it's very great, but going forward, the AI is going to be so advanced. Mark my words. So you guys will feel like if you have watched some AI and robotics movies, you will feel the same way. Just swipe like this, the screen will move like this. Then if you give a command, then the model will start to work. It's going to be very interesting going forward. The end-to-end process of input and output. So normally these all LLM models are nothing but they are called as a black box models, because what is an internal architecture of this particular models, it's very difficult to decode, and how it is going to create and how it is going to generate the output, it's unknown to everyone. So you should try to know the input and output process of a particular model. before you perform an operations, or you can say before you deploy model somewhere, you should know the operations of it. So if you want to learn generative AI or an LLM architecture, I have already created a generative AI roadmap video as well previously. That video link will be in this video description. You can check out that, and it's going to be very interesting. Okay, and you have a clear picture there what you all need to learn to become an generative AI engineer. So check out the video. The video link will be in this video description. Tokenization. So when it comes to tokenization, you have techniques of tokenization, like how you are going to tokenize a model in LLM models that you need to understand, and implementing tokenization in LLM pipeline. So you have to first tokenize the model, right? Without tokenization, you cannot perform or you cannot work with an AI models, in short. So those who are doing programming, they might know about this. So you have to split the model data as well. If you are going to fine tune the model, you have to first create the model as a chunks, and there is many more process in it, right? Embeddings. So overview of embedding layers in LLM and generating embeddings using pre-trained models. Embeddings are nothing but, you can say, your vectors, or you can say a number of vectors, okay, so which you have to create and store it in a particular database, or if you want, you can embed the data and you can provide the embedded data to your model. Okay, so when it comes to embeddings, you have many open source embeddings, like you have Hugging Face embeddings, and even you have, you can say this one, what is this, from Quadrant you have, and from OpenAI you have. There are many embedding models as there, fast embedded models are there, and even you have Olama embeddings as well separately. So you should know about all these particular embeddings. So those who all are thinking that only here all the overview I'm explaining, there is an GitHub repo. Okay, so I'll be providing this repo link also in this video description. It's called as Awesome LLM Ops, where you have complete decoding of it. So about LLM Ops, so what all are the things you should have, you know, here you have a table content. Once you have all the tools which you should know, so what all are the large language models you have for code and documentation, you have Apsika, and you have Dolly, Gemma, and Chat GLM 26B. These all are your models, Mixtral 8x7B model. So these all are some of the models which you all should know. You can refer them. And for CV foundation models, that's computer vision foundation models, which you have Disco Fusion, Midjourney, Segment Anything, Stable Diffusion models. Audio models, you have separately Bark and Whisper. And for large models, for serving. So what all are models you should learn? All those models are defined here. For serving, what all you should know? You should know Llama CPP, you have Olama, you have Deep Speed ML, and Apsika LoRa Serve you have. Sorry, Alpica. This is Alpica LoRa chatbot service you have. So I'm bad at you can say I'm bad at pronouncing some words, so don't mind it, guys. Frameworks for serving, you have Bento ML, you have Jinja, and LangChain, LangServe you have from LangChain, Xinference. So all the frameworks which you should know and which you should learn, there is a curated list on it. Okay, I'll be providing this particular entire GitHub repo, what all things you should know in detail. So you have for security as well, you have plexiglass. So for security, you can use this for protecting your model from attacks. And for LLM Ops, what all you have AI Studio, Agenta, and Budget ML, Comic LLM, Deep Lake. I guess many of them haven't heard about this as well. So many of these tools, even I haven't heard as well, to say frankly. Some I have used it. Haystack I have used Haystack, and from LangChain I have used Langflow and Llama Index. So those who all don't know about Llama Index, it's an alternative to the LangChain framework, you can say. They all are frameworks. You should know about them. For prompting, this is for prompting, I guess. You have Prompt Hub. There are many tools which you guys should know. And for vector search, you have LansDB, Melvis, Markiv, Pinecone, PG Vector, Quadrant, and VectorDB, and Valium. So these all are some of the important databases, you can say vector databases, which are right now in trending, and many of them, I guess you all know. If you have worked on some RAG projects, you all might have used Pinecone, or you have used Quadrant, even you might have used ChromaDB, Fayaz from Facebook. So all these databases you might have used them. Code AI, Code JX, and Code T5. So this is a T5 model upgradation, you can say, and Tabby. IDEs and their workspaces for training. You can use Jupyter notebooks, or you can use Docker, ENVD, and Conda server or code server. So there are many things which you guys need to know. You can just refer this particular repo. Everything is detailedly explained here. Foundation models also you have. So Alpaca, LoRa you have. Fine tuning schedulers. So these all topics, I cannot explain them very clearly to you guys, but all these topics, if you can just open, for example, if you want to learn about Alpaca LoRa, just open this in a new tab. Immediately you will get about it. So you will get here how to set up it and how to use this particular model. So make a list. So this here which you are seeing right here, I'm going to explain you the overview or how you should learn. What is the process to become an LLM ops engineer or to learn, and you have tools in this particular GitHub. What all are the things you should learn? So follow this both, you will easily become an LLM ops engineer, I can say. Attention mechanism. So understanding how transformers models work. So if you all might have already learned NLP, you guys might know transformers. There is another name, or you can say initially it was published with the name called Attention is All You Need. If you want, you can refer that paper. It's going to be very interesting. And soon I'm going to come up with Transformers series as well, where I'm going to deeply explain about Transformers model, its architecture, and why it's called as a black box model, everything. Exploring different types of attention mechanisms. There are self-attention models and multi-head attention models. So I'm going to explain about all these topics as well. You should even learn about them. So first learn attention mechanism, and Attention is All You Need paper. It's very much recommended. So read that particular paper. Text generation. Techniques to generate coherent and relevant text. And implementing sampling methodologies like greedy and beam search. So you should know about all these particular search technologies or search methods, and how can you generate text, how the text generation process works. So you should in short know about LLM model from starting to end, you can say. You should know about GPT, for example. So how the data is going in GPT. So what is internally happening in GPT, what all are the layers it is having. I'm not telling about the black box model which ChatGPT uses. I'm telling normally the model which you guys are going to import from Python library. Okay. So what is its input and how it is getting trained, and what is its output. So the pre-trained models. You should know about these particular topics. So after the architecture, you should know about running an LLM. Okay. So the LLMs are again divided into LLM APIs, open source LLMs, and prompt engineering. So when it comes to LLM APIs, so you have API based models, you have Grok, you have OpenAI, and even Mixtral is right now an API based. So you should learn an overview about these particular models and how to access them. Authentication methodologies and API key managements, how they work. And finally, how you can make requests and how can you handle the responses. So in short, if you are going to work with ChatGPT, you can, or else OpenAI API, how you are going to ask the question and how the model is going to respond, and what is your response on that particular answer you get, and how you are going to handle those responses. You should know about all these particular topics. And what's the code structure also. You guys have to understand them very clearly. Open source LLMs. So you have some of the famous open source models, you can say, like you have Olama, and again Grok. You can say Grok is an open source only. You can just create APIs and use there. You can use or access open source models using Olama, Grok, and also you can use Hugging Face models. You can say you will get them in Hugging Face models, and very soon you guys will get even GitHub models as well. So recently, if you are following me, you might get to know that there is a GitHub which recently launched called GitHub Models, where you will be able to access all the models from GitHub itself. So you can directly write the code from GitHub. I mean, you can pull the code from GitHub and write the structure for it, and you can push the model to production. So we need to see about it. It's officially not out. They have just announced it. setting up the environment to run these models. So open source models are different from APIs. When it comes to APIs, you guys have to give an API key and write a structure. But when it comes to open source models, you have to first configure the model locally so that it can run in your laptops. That is more important. So you have to know about how to set up them and fine tuning the model with custom data. It's very important for both APIs and even for open source LLMs. We should understand how you are going to fine tune model and what are the methodologies, what is LoRa and what is QLoRa. QLoRa is nothing but quantized LoRa. So you have to understand about all these particular topics. Prompt engineering. So once you know about all these topics, you should know how effectively you can write prompts. So you have to mainly give commands. So prompts are nothing but the commands which you are giving to your model. You are restricting it to that particular command. You are ordering it. You should only work on this. Apart from this, you should not work on any other technologies or any other questions. If anyone asks, you should not respond that. So you should understand how effectively you can write prompts for it. Crafting prompt for various tasks. So you have to custom design prompts, or you can say custom write prompts in a very clear manner, and you should provide them for various tasks, because many of them might use LLM models for their respective use cases, and every industry will have their own use cases. So some might be working on manufacturing industry, some will be on healthcare industry. So respective of their industry, so the prompts will be changed and it will be different. So to understand them, you should know prompt engineering. You will get many YouTube videos on prompt engineering. You can refer them as well. Running LLM. So building vector storage. So when it comes to building vector storage, you have it divided into ingesting documents and splitting documents, embedding models, and vector database. So when it comes to ingesting documents, techniques for importing and preparing documents. So they can be a PDF or text data or anything. Those are considered as documents. So you have to understand the techniques. How can you import them? So there are some tools when it comes to PDF. You have PyMu PDF or PyPDF Loader, or you have even PDF Plumber. So you can use all of them. And data cleaning and pre-processing steps. So how can you clean the data, or you can say how can you clean the unstructured data? How can you create them into chunks? So these all are topics which you should know properly when you are ingesting the data. Splitting documents. So strategies for dividing documents into manageable chunks. This I already explained you all, how you are going to divide them into chunks. And sentence tokenization, you have to tokenize and create, and paragraph splitting as well, you have to do it. So this you guys have to know properly. So this works even for RAG as well. For RAG also you guys follow the same step, right? So if you have watched my MongoDB video, I guess, RAG using MongoDB, if you haven't watched that, you can check out. I'll update that video in this video description. There I have used everything open source. I used Olama and Llama 3, I guess. Llama 3, and I used MongoDB as my vector database. So that video is going to be very interesting. You can check out that as well. Embedding models. Overview of embedding techniques. So you have different embedding models, as I explained you all. You have OpenAI embeddings, Hugging Face embeddings, and different embedding models. So generating embeddings from those text data and understanding the semantic similarity. So semantic similarity is nothing but you can say cosine similarity. If you know maths, and in maths, if you have heard about cosine similarity, you will get about this particular topic and its applications. Vector databases. Then after these all, you have to understand about the different vector databases. So you have Pinecone, Chroma, Quadrant, and right now even you have I guess many more databases, like you have Fias, you have, and some more new databases also are out. You can check out them on this particular list here. So I'll get them in detail. Storing and querying vector representation. So you should know how to store and query those particular vectors, and indexing strategies for effective retrieval or efficient retrieval. So storing data in a database is not a big deal, but you should even know how to index it and how to retrieve those particular data as well. That's the main key point. So for that, vector databases you guys should know. Then you have RAG. So finally we are with RAG. So overview of RAG. Understanding what is RAG or retrieval augmented generation and components of RAG, that is retriever, generator and memory. You have to understand about these particular topics in detail. Orchestration, so tools for managing data flow. So you have Apache Airflow for this, and even you have many other for data streaming as well. You have Kafka, and many other tools are there. So as I mentioned, check out them in GitHub. You will find those all the tools details list. Okay, so it's already available in that GitHub. And retriever, so mechanism for fetching retrieval documents. So we can use semantic similarity search. You have techniques like BM25 and dot product. So there are many other different techniques how you can retrieve a particular data. It depends on how you are going to retrieve it and which method suits for your particular product, you can say, or for your particular application. Memory, implementing memory management system to retain context and improve interactions. In short, for example, like if you are a user and you have a knowledge base where you are going to ask questions. So if that knowledge base answers your question, that's fine. But if you want to update, so if you want update on previous question, how it will do? It doesn't have memory. It will just take the question and it generates and it becomes forgets the things. So for that, what you can do, you can implement. There is separate functionality you can say called memory, which you can inbuilt or you can build it with that particular product. You can take example of RAG itself. So whatever questions you previously asked, it will remember that. So that's one of the main advantage here. Evaluation. Methods of accessing and performing a RAG system. In short, here you have to evaluate the model performance as well. Once the model has been created and you are getting the answers, retrieving is going on, then you are getting the perfect answers. You have to evaluate it. Here you have again different evaluation methods like human evaluation you can do, and even if you have some other document to compare, you can compare with document evaluation. There are different techniques, but mostly RAG evaluation, it depends on the document and human evaluation, how many times, or else you can say how many times it is generating the same answer without the mistakes. Okay, mostly human in loop comes in, so we have to check about that in RAG. So after RAG, you have advanced RAG, query construction. So in query construction, you have techniques for formulating effective queries to retrieve relevant information. Understanding user intent and context in the query formula. So here in query construction, you need to understand what is the user's main aim, or you can say what is the user's main expectation, and based on that you have to build, okay, the product. Agenting, or you can say agents and tools, utilizing agents to perform tasks and privilege tools. For example, you can use agent based systems like chatbots, virtual assistants, and here you have no human in loop. Only the human in loop is for evaluation, but normally everything the agent will do. So if you ask question, the agent will answer the back things, and even it will maintain if there is some hallucination. For example, if the chatbot has given some data and it's hallucinating, you can add an agent there to check and verify whether there is an hallucination. If hallucination is there, then it will again send that report to the generator, or you can say the retriever, where the retriever will again check the question and regenerate the answer. So until there is a proper output, you can use agent there. That's an example. Post processing, techniques for refining and improving model output and enhancing coherence and relativeness of response. So these are post processing. So once the agentic tools are done, you can even use this as well. Re-ranking and filtering, methods for selecting the best performance from multiple outputs, techniques for scoring and re-ranking outputs based on relevance. So you can actually filter it. So if that particular model is giving a result, you can score it. The data which is high score matching, or you can say high semantic search you're doing, and which is having high correlation, only that data should be out. So you can use K method in RAG and you can print that first two responses. Okay. So this you will understand when you are writing the code itself, or else you don't get it. Hierarchical indices. Benefits of hierarchical indexing for efficient retrieval and techniques for building a query hierarchical indices. So hierarchical approach also is required. Hybrid document embedding. In short, hybrid document embedding, in the name itself, you have that combining different types of embeddings for improved retrieval, understanding the benefits of hybrid embedding. So these are the things you need to understand. So hybrid embeddings, in short, you can say you might have multiple formats of document. It can be in PDFs, CSV, not CSV, PDFs, text, and even XML documents. There can be different types of document methods where those methods are provided to the retriever, or you can say the embedding vector database, for better understanding. The retriever will retrieve the data. Content enrichment. Techniques for enriching received content with additional context or information. Method for integrating external knowledge source, example knowledge graph. So to enrich the content and to evaluate, you can say, for better evaluation of the users, you can add content enrichment methods, or you can use even integrate a knowledge graph where it can identify from where it can validate, in short. So your answer is fetched from here, and that source you can refer as well. That you have in Perplexity, I guess. So in ChatGPT, if you type something, you will not get the output source from where it's picking. But in Perplexity, if you ask some question, at the down, you will be getting the links from which particular sources at the online it picked. Okay, that's one of the main advantage. Fusion retrieval hybrid search. Principles of combining multiple retrieval methods for improving accuracy and relevance. Techniques for integrating keywords and semantic search. So this can be followed. Like you are going to fusion, you have to combine multiple retrievers, and hybrid approach should be followed for better performance. Inference optimization, you have flash attention model, so you can use either flash attention model or key value catch. Techniques for optimizing attention mechanism in transformer models, we use flash attention. Key value catchy, implementing catching strategy to speed up inferencing times. Speculative decoding, techniques to predict and generate outputs more efficiently during inference. So there is a better speculative decoding. So you have different methods to encode. I mean, you can say output whatever you received, you are going to decode it in different methods to understand the better retriever. Securing LLMs. So guys, before that, if you haven't subscribed the channel, do subscribe the channel, and here you have my link attached here. If you click on this link, you will immediately redirect to my channel. And those who are watching my video, so guys, now only you can subscribe the channel, this video who all are watching. Securing LLM. This is one of the most important method, you can say. So creating an LLM model and bringing it to the production, it's very, you can say it's a tough task, but the more tough task is to secure the LLM. Whatever you are going to, you have to maintain those particular loopholes where the cybersecurity experts or the hackers can hack your LLM model, and it can hallucinate a lot. The main thing they can do is prompt hacking. So understanding vulnerability in prompt design and how to mitigate them. Conducting a security audit of prompt designs. In short, what prompt hacking is, so the hackers will find out the loopholes in your prompt. So what loophole prompt they can enter to overcome your prompt and can generate what is their expectation, or can get the information. Backdoors. Identifying and addressing potential backdoors in LLM that could be exploited. Implementing test procedures to detect backdoors. In short, here what happens? So you're creating an LLM, in a sense, the hackers will have multiple ways to enter. So in backdoor, in a sense, you have to secure each and every place. If you just leave a small loophole, for example, if you directly integrate API in your code itself, users will get your API. So there are different methods. You have to use .env method. So you have to be very secure with the backdoors. Small sensitive information, if the user get a small point, if they get also, they can easily hack your LLM model or your product. Density measures. Strategies to secure LLMs against various threats, and developing a security framework for LLM deployment. So it's okay. Defensive measures. Sorry. Yeah. So what all are the defensive measures you can do? You can create a strategical methods. What are strategies you can plan, and you can even create a defense firewall for your LLM model. So I'm just telling about the firewall. You can create it where the users, when they try to enter, you immediately get the notification or something. The walls cannot be hacked, like how you have for your system of firewalls. LLMs, VLLMs. Techniques for serving LLMs efficiently in production environment. Deploying a VLLM model in a production environment. So for serving, you can use VLLM, where you need to understand what are the techniques to use in production environment and how can you deploy your LLM model. C Translate 2. Benefits of using C Translate 2 is for fast inferencing, deploying a translation model using C Translate 2. So for translation model, if you want to do better translation, like from English to German, from German to French, if you want all those translation metrics, or if you want the model to do all these methods, right, you can use C translation, where you can easily perform these operations. MLC LLM. Frameworks for serving LLM's capability and efficiency, experimenting with MLC LLM for model serving. So this can be done. So for better serving and flexibility and efficiency of the model, you can use this. So serving is fine. How you are going to deploy the LLM? In local you can deploy, or in cloud environment you can deploy. So local, setting up the local environment and testing the model, develop and testing, creating a local environment variable and LLM experimentation. Here you can use Olama. If your laptop GPU configuration is very high, Olama supports. So you can bring entire architecture in your local itself. Serving, or you can deploy even at server or cloud as well. Strategies for developing LLMs in cloud environment. You can deploy it on AWS, Google, or any of the cloud services, and you can understand that architecture as well. So when it comes to cloud, you have secure secret managers and different services which you can use and deploy, and even your data might be very secure. And also the deployment, however, you have to bring into production by deploying on the cloud itself, cloud servers. So if you want to bring your product live, that you can use them. Frameworks. So this frameworks, everyone should know, whether you are an AI engineer or an LLMOPS engineer, everyone should know there are LangChain frameworks. So you have to understand what is LangChain framework and how can you build applications using LangChain. LangChain, you can say it's very good framework, or you can say it's very nice framework, where the documentation is very simple and you can easily understand the entire code flow, and you will get the structure properly in LangChain. The documentation is perfect. Same goes for Llama Index as well. So in Llama Index also you have the documentation very well, and it's an alternative to LangChain, you can say. So whatever, there might be some features plus or minus in both. So in LangChain, if there is one functionality, in Llama Index that functionality might not be there. There might be one more unique functionality. Both are very important. Like how you require, you have Flask and even not Flask. Yeah, Flask and Django for developing the backend. You have both the frameworks. You have TensorFlow, and then you have TensorFlow, and then I guess Py. And when it comes to backend, you have TensorFlow and PyTorch. So any of them, both of them are very good. So most of the times, if you see, the LLM models are written on PyTorch mostly compared to TensorFlow. Google uses TensorFlow because it's their own in-house product. Chainlit, you have Hugging Face, and you have even Gradio. So Gradio is for bringing, or you can say to bring the interface on. Even Streamlit comes in here instead of Gradio. You can use any of them. But you should understand what is Chainlit, even Hugging Face. So from Hugging Face, you can bring out all the models, and understanding the Hugging Face framework and how to import models from that as well. So guys, I hope you all understood the architecture of LLMOPS. You all can refer this particular roadmap. I'll provide this link in this video description, and also especially this particular AIOPS roadmap, which you all can refer. It's going to be very interesting. So that's all for today's video. Do like, share, and subscribe the channel, and make sure to share this video with your friends who want to learn LLMOPS and even AI, you can say. So guys, that's all for today's video. Meet you all in my next video.